So here we have circuit 1 double I, and it's almost the same as the previous circuit, but with the 1K resistor replaced with an LDR, also known as a photoresistor, and we're still using 9 volts as our power supply. And right now the circuit is on, the LED is on, and when I place my finger on top, there is no change. And the reason for that is that since in reference to this resistor, to the 2K resistor, the LDR resistance is too high, in which the voltage remains at a this fixed value, in which the transistor remains on even in light and dark conditions. So in order to fix that, we need a higher resistance here in this top resistor, greater than the LDR resistance. All right. So we replace the 2K resistor with a 200K resistor, and when I turn the circuit on, it's off. The LED is off, and then when I place my finger on top, the LED turns on, which works. Since compared to this resistor, to this 200K resistor, the resistance is low. Hence, the LDR's voltage decreases to a value lower than the transistor's turn-on voltage, which remains off until I put my finger on top, which increases the resistance, increasing the voltage to a value greater than the turn-on voltage, which turns the transistor on, hence turning the LED on. So here we have the PNP configuration. So the voltage is still 9 volts, and as you can see, with 2K, there is no effect. Since compared to this resistance, the LDR's resistance is high. So now let's see what happens when we replace it with a 200K resistor. So here it's replaced with a 200K resistor. The circuit is on right now, and when I place my finger over the LDR, it works. The same effect as the NPN configuration.